Hi, this is Ryan, and I'm going to be sharing a use case that we had for Helix here at Lawrence Livermore National Lab, where we coupled GridDyn and GridLAB-D for a simulation. So for this use case, we simulated several variations of the IEEE 123-node test feeder distribution model and coupled 3 instances of each variation of that model to buses in the WEC 179 bus model. And we used GridDyn and GridLAB-D to simulate those models. So we needed to synchronize the simulation time for GridDyn and GridLAB-D. And then we had the load for the coupled buses in the WEC 179 bus model. It was used in GridDyn, coming from a copy of IEEE 123 node model running GridLAB-D. And then in return, the voltages for the coupled buses in the WEC 179 bus model were sent from GridDyn to GridLAB-D. So that setup looked like this. We had one instance of GridDyn running, and then we had 3 copies of GridLAB-D running. And each copy of GridLAB-D would send its load to GridDyn as the load value for a bus in GridDyn, and then it would get the matching voltage for that bus and send it back to GridLAB-D. So in total, we used about 4 federates. There was 1 GridDyn federate to simulate the WEC 179 bus model, and then 3 GridLAB-D federates, each running a copy of the IEEE 123 node model. And then optionally, recorder federates could get added to the simulation as well to get out the file or of load and voltage values shared at each time step, mostly for debugging purposes. So when you add Helix into the mix for communication, it looks something like this. We had a Helix broker, and then GridDyn and 3 copies of GridLAB-D connected to it. And each federate, GridDyn and the 3 GridLAB-Ds would publish a value, and that value would get sent to the broker, which would then send it to any subscriptions. So GridDyn was sending voltage values to using Helix, and then GridLAB-D was sending load values. And then the subscriptions, GridDyn would receive the loads for the various buses that GridLAB-D had published, and the GridLAB-D instances would get a voltage value that GridDyn had published. So we used Helix to handle the time synchronization and the communication of load and voltage values between GridDyn and the 3 copies of GridLAB-D. And we used both GridDyn and GridLAB-D as value federates, which basically means that they publish a value that other simulators can then subscribe to and get updates when that value changes. So we didn't send any messages, just published and subscribed to values. And most of the communication was using the 0MQ core for Helix, typically on a single machine, but when trying it out initially, I did some runs involving the broker and GridLAB-D running on a Linux system and GridDyn running locally on my laptop, and those seem to run just fine, if a bit slower than on a single machine. So the challenges that I encountered while setting up this use case was that I was using an old version of Helix. I think it was around version 0.3 or something, which is a bit less stable and lacking in some features that have been added since then. Probably the biggest challenge was starting up the simulation, and the solution I had was writing a bunch of scripts. So the startup order was important. I needed to get the broker launched first, and I need to give it the number of federates that would be connecting to it, which if I added some recorders, that would change the number, so I can just hard code it. Starting everything using a single terminal was pretty cumbersome, and so writing a script to handle launching the broker and federates as background tasks greatly simplified that. And then while a single simulation was running, I could be doing other things, since it's no longer, the Helix simulation was no longer occupying the entire terminal. So I could go in and look at the output from each of the federates and see if they are doing what they should be. Another trick I found with the script was redirecting standard output for each federate to its own log file. It was useful for seeing what's going on. The output and the log files would update as the simulators were running, so I could open up the log file and see, okay, GridLAB-D has reached this time step. GridDyn is still running. Nothing's crashed or hung yet. On a related note, since sometimes things would hang, storing the PID files for the federates and broker when they got launched in sort of PID files was useful, since then I could add a kill command to my script that would read the PID file and then kill all the federates that it had automatically launched for the simulation. If I noticed that something was going wrong, I needed to fix a bug, like in my configuration, I could type one command and kill all the federates that have been started. And there are a lot of variations with slightly different input files that need to get run, so having a script to submit a bunch of batch jobs using the launcher script helped make that a lot less tedious than sitting there waiting for one simulation to run and starting the next simulation with the right set of other input files and so on. And then same for output. Some of the GridDyn output files have the same name for each simulation run, so setting an output directory for each run in the script helped make things, keep things a lot more sane and organized. Other challenges I encountered were that the values sent and received by each simulator didn't necessarily have units attached to them, or the values were interpreted with different units. So figuring out what units the voltages values GridDyn was sending with was a bit tricky, and making sure that GridLAB-D was interpreting those incoming values in the correct way. Found that the base voltage units equals V or kV configuration option for GridDyn loads was useful, since I think the default in GridDyn was sending the values as kV, whereas GridLAB-D was expecting volts. So just by adding the base voltage units equals V line to the GridDyn configuration, GridDyn would start sending it the value as volts instead of kilovolts. Similarly, for the loads that GridLAB-D was sending to GridDyn, setting the units to watts in GridDyn made so that it interpreted the values correctly. And the scale factor parameter in GridDyn was also useful for just scaling up the load value some from what GridLAB-D was sending it. So in our case, we had to multiply the load by a factor of 40. So while working on the simulation, there were they were testing some things with different model files, so I'd often receive a model file with small changes that wouldn't have the helix-related configuration stuff that I'd added to the model file. Since there's a lot of back and forth where that happened, I created a wrapper configuration file for GridDyn and GridLAB-D that had all the helix-related setup stuff that created the helix publications and subscriptions. And then I just kind of import or include the main model configuration file and include it within that wrapper so that when I received an updated model file that no longer has the helix stuff in it, I can just drop it in the directory and then continue running the simulations without any other changes. Getting the time steps set the same thing in GridDyn and GridLAB-D was stranger than it should have been. I don't know entirely what was going on. I think that since it was a pretty early implementation of the helix interface in both of those simulators, there are strange things going on that shouldn't be encountered now. But GridDyn had its time steps for simulation set to 15 minutes, and GridLAB-D was simulating 1 second time steps, and for some reason, the time step sizes just didn't want to change, so the overall simulation was, the simulators were running in 1 second time steps for whatever reason, so it took longer, but I think data exchanges happened at roughly 15-minute intervals. So in the model that we were simulating, the data changes hourly, but a few iterations were needed for initial convergence. And early versions of Helix didn't support iteration, or it wasn't working well in those early versions. So that's why I had to simulate time steps at 15 minutes in GridDyn. You basically let simulate 4 time steps per hour, and then just the last of those time steps as the result for that hour as a sort of poor man's iteration. In new versions of Helix, iteration should be working fine. And overall results from our use case, we did 120 simulation runs with 120 simulations, so 120 different variations of the input model files. On average, a simulation run took 35 minutes, and the output deliverables were a GridDyn output file for each of the coupled buses containing voltage, angle, and real and reactive powers, and a series of GridLAB-D output files that had powers, voltages, and loads for various nodes. Any questions?
Ryan, quick question. Is this model available out on the repository for others to try?
I don't think so. I need to check to see if it's okay to release, what parts of the model are okay to release. I think I could probably make it generic though and release something, since it's the WEC 179 model for GridDyn, which I think is included in the GridDyn repository. And then the IEEE 123 node model for GridLAB-D I think is also publicly available. Yeah, I could see about putting together an example that could be uploaded somewhere.
Great, thank you. Are there any other questions for Ryan? All right, well, thank you very much, Ryan.